today's topic is a building block to secondary school mathematics, and a thorough understanding of it is essential. Welcome, viewers. With me in studio are two students, Henry.
Welcome, viewers.
And Mariam.
Welcome, viewers.
Good. As I said, our topic is on logarithms. Now, we cannot start talking about logarithms before we remind ourselves how we can express or write numbers in standard form. So I'm going to take us on a brief review on what standard form is before we start on logarithms. Now, the standard form. Standard form. Now, a number is in standard form if it is expressed in the form of a times 10 to the power of n, where a is a number between 1 and 10 exclusive, and n is a positive or a negative integer. And n is a positive or a negative integer. So we're going to consider an example to see how we can express numbers in standard form. The first example. Express the following numbers in standard form. A, 759. So the first step in this, we try to locate where the decimal is by inspection. For example, in this number 759, where is the decimal, Maria?
It's after 9.
Yes, the decimal is after 9. So we move the decimal either towards the right or towards the left, so as to reach to a. Remember, the standard form of is a times 10 to the power of n. So by inspection, we realize that the decimal is after 9. So we have to move it 2 steps to the left. From here, up to here, up to here, so as to arrive at a, which is 7.59. Okay? It's a number between 1 and 10 exclusive. Then, times 10. Now, our n now will be the number of steps we have moved towards the left. In this case, how many steps have we moved, Henry?
2 steps.
2 steps, correct. So it becomes 7.59 times 10 to power 2. That is the standard form. Now, if the decimal moves toward the right, the power becomes negative, as we shall see in the coming example. So let's consider another example, part B. It is 0.000701. Now, by inspection, or rather we can see where the decimal is. So now we are going to get our value a, which is a number between 1 and 10. And I want Marion to try and give us the value of a, please.
Which will be 7.01.
7.01 times
10 raised to power negative 4.
Negative 4. That is very correct. That's very correct, because by inspection we can see we've moved how many steps? 1, 2, 3, 4 to get to 7.01. Okay? So the important point to remember here is that when we move the decimal towards the right, the power becomes negative. And when we move the decimal towards the left, the power becomes positive. So that is very important to remember, because our logarithm tables, they are set in standard form. All logarithms in this table are set in standard form. So that's why it is important for us to remember on that. To illustrate the concept of logarithms, we are going to consider some powers of 2. We are going to consider some powers of 2 in index form as follows. We start 2 to the power of 0. The answer to that, Mariam?
It's 1.
1, correct. 2 to the power of 1, Henry?
It is 2.
2, correct. Then 2 to the power of 2, Mariam?
4.
4. 2 to the power of 3, Henry?
It is 8.
8. And lastly, 2 to the power of 4 is 16. So these powers can go on continuously up to infinity. Now, the powers to which 2 is raised, 0, 1, 2, 3, 4, and so on, are called the indices. They are called the indices, the powers themselves. And 2 is called the base in this case. Are we together? Now, the powers, once again, 0, 1, 2, 3, 4, and so on, are called the logarithms of the corresponding numbers 2 base 2. Express these powers in index form and in logarithmic form. So we can have index form, logarithmic form, as follows. Now we've said 2 to the power 0 is equals to 1. Now I'm saying the power is the logarithm of the corresponding number, which is 1 to base 2. So in this case it will be the log of 1 to base 2 is the same as 0. Can you see the relationship? Good. Let me do another one for you. 2 to power 1 is equals to 2. Now I think, Mariam, can you try expressing that in logarithmic form?
The logarithm of 2.
The logarithm of 2
to base 2
to base 2
is 4.
Is equals to 1.
No.
Remember the power always is the log. Remember the power always is the log. You can see you're following. 2 to the power of 2 is 4. So it is the log of 4, isn't it?
So yeah, log of 4
Base
2 is equal to
is equals to
2.
2, correct. Let's try another one. 2 cubed is 8. Marion, can you try?
The logarithm of
8, correct.
to base 2
To base 2
is equals to 3.
is equals to 3. The last one, 2 to power 4 is equals to 16. Henry, once again.
The logarithm of 16 to base 2 is equal to 4.
Is equals to 4, correct. So it is very, very much important to know how to express numbers in index form and in logarithm form. You can see, for example, 2 to the power of 0 is 1. So we get back to our index form once again. Log of 2 base 2 is equals to 1, for example. So this 2 is called the base. This one here is the log. And this 2 is the number, okay? Is the number. That's very important for you to remember. That's very important for you to remember. Now, with that insight now, we can introduce ourselves to the use of logarithm tables. Now, this is a recommended logarithm table by the Kenya National Examinations Council, and we advise students to practice using this table because this is what they expect during their Form 4 exam. Now, the logarithm tables. Viewers, as you can see, this is how the logarithm table is set. There is a column headed X, which is giving the logarithms of numbers from 1.0 up to 9.9. And that is why it was very important for us to remind ourselves of how we express numbers in standard form. Now we also have other columns in between. Column 0, column 1, 2, 3, and so on up to column 9. Those are the logarithms of the numbers headed from the column X, which are given correct for significant figures. Now, to the extreme left of the table, there is another table called the difference column, whose values are added to the logarithm of the values in X, which we shall see in practice as we come to a particular example. So we now can go to our logarithms and see how we can apply them. Now, the logarithm of a number consists of two parts. The first part is called the characteristic. The characteristic of the whole number part, which can be positive or negative. The